Are we good? Okay.
Howdy! Okay, we finally made it to the end of HowdyHack. Congratulations, everyone. Woo! We are so happy to see all of y'all here, and we hope that y'all got a chance to meet some cool people, learn some cool stuff, and create some cool projects.
Yeah, so this weekend we had over 200 hackers total and over 75 project submissions. And this is actually the most submissions we've ever had at a HowdyHack. So congratulations. We're really proud of everything that y'all have made. And now, without further delay, let's just get into the most important part, which is the prizes. So as you can see here, we had the mini events we had in Discord, and here are the winners we chose for them. So if your name is on here, this is your Discord username. Reach out to us after the event if you're in person, or if you're on Discord, you can just message us and we'll reach out with your gift card.
Okay, so now let's get into the hackathon tracks. So this was initially the most impractical, which was meant to be a joke challenge, but everyone who submitted to this track just happened to be really amazing and worked really hard on their project, so we added a small $10 gift card in addition to the squeeze chicken. The lucky winner of the judge's choice is Mello! Woo! Come on up.
We got the gift cards. Got the gift cards, right?
They get a drink.
I just talking about it. I want it to my new toothbrush. Yeah, he can get a toothbrush.
One for each person. Yeah. We're good. Right?
Yep.
What?
Can,
You want to take a photo? Yeah. Should I take a photo?
I think,
1, 2, 3. 1, 2, 3.
okay.
Congratulations, Bill. Thank you.
Awesome! Yay!
Today's calling me.
So the next is the best music-related hack, which is the theme of this year's HowdyHack. The team that won the Bluetooth speakers is Pitch.io. Come on up! Woo! Congratulations, y'all.
What's the next one? Best UI? Okay, I got it. Don't click next first.
1, 2, 3.
And now for the best UI. So we saw a lot of great UIs here. Like this is a mostly first-time hackers here, but we saw a lot of like great design. So thank you so much for putting a lot of work. And the UI for this team who won best UI is pretty crazy. Yeah, I highly recommend y'all check out that dev post once the event is over. So the team that won is Chime to Play. Come on up.
So this team won the Polaroid cameras. Yay! Woo! Okay, so the next challenge is the Aggie. Since this is Aggie only hackathon, the next track is the best Aggie hack. The team that won this challenge is Aggie Run, and y'all must be the loudest and the proudest fighting Texas Aggies of HowdyHack. Woo! They won some very cute and awesome Reveille pillow pets. They're all wearing. Or, yes. Okay, so next we get to watch the top 5 project demos. After these teams demo, the judges will decide what the top 3 overall projects are. The teams will get to choose between noise-canceling headphones, mechanical keyboards, and mini projectors. Okay, so let's get a drum roll. Can we please welcome Isolate, Pitch.io, Vism, and Moodify, and Party Vision. I think the last 2 are virtual, but the rest of them should be here. Woo! Yes! Woo! So I think Isolate is coming first. If y'all could get ready to demo for us and come up to share your screen. Do y'all have a Mac? No?
We have an HDMI for it.
Okay, yeah.
Yeah, so it should be good.
Just leave it on for them. Y'all got this. Y'all are amazing.
I did Gangnam Style. I can do this.
Yeah, exactly. If you could do Gangnam Style.
Yeah, it works. Here, okay. So.
All right, just present.
I hope the
That's fine. That's fine.
the mouse is gonna-
Howdy. I wanted to do that. Okay, we are Isolate. What is Isolate? You know, Isolate is a program that makes practice more efficient for any instrument there is. Isolate creates a schedule that allocates time for the optimal amount of practice for sheet music. All of us have backgrounds in instruments in our past, like, high school days. And basically, what we all found in common was that it's hard to look at a sheet of music and determine what parts you need to practice, and also what parts maybe you don't need to practice so much because you're just that good. So what we did is we wanted to take away that kind of issue. So how does it work? Presented here, we start off with a MIDI file. A MIDI file is basically a computerized version of a sheet music. And what we do is we put it into our first UI, and that UI then brings it into an algorithm. That algorithm separates the notes into sections. In these sections, we have different rankings that we all as a group decided together is universally just what makes a piece harder. So fingering, intonation, and rhythm. These are the 3 categories that we have used. All of them together create a final ranking. And these 5 things then go to our second UI, which is displayed back to the user. And each of these, if you can see the little purple box, they're in different measures, and they're shown to have the different rankings. And with each ranking, there's a given practice time. So you'll know what you need to practice a little bit more, and what you don't need to practice, or what you need to practice like a lot. So I will hand the mic over to William, who will talk about the UI.
All right. So I was in charge of the UI and also kind of like structuring the project. And so we all come from Java backgrounds. And so I went with Java FX just because it has like the scene builder tool. And it's really easy to just build a program. And so you open it up, has enter the directory of the files. I will use something called file directory. You go in, you find your MIDI file. Okay. Oh, all right. You find your MIDI file. Sorry. Oh yeah, all right, there you go. You find your MIDI file, you open it up, it gets the URL code, it sends it through the whole cycle, so the algorithm and then the MIDI computer. And you go up here, it shows each measure. And I get this data from the difficulty algorithm, and then I have the buttons mapped to the MIDI class, and yep. I'll go ahead and hand it over to Jeffrey, who will explain how we got the difficulty ratings for each one.
Okay, so let's see. Going through the measures, the first thing you'll notice at the top is this thing that says practice for so-and-so minutes. This is kind of like the ultimate result of all these ratings. You'll see, based on the overall difficulty rating, we determine how long you need to practice. So like third measure is like 5 to 10 minutes. Fourth measure, just like less than 5 minutes. Now there are 4 numbers here. for different ratings. The first rating is for fingering, and this is kind of like the frequency of notes. Essentially, the more notes there are in the measure, the harder it is to play. So that's for fingering. The next is intonation. Huh? Oh, okay. My bad. Next is intonation, and this is kind of the change in pitches. So if there's like a song that's going between low and high pitches all the time, it would be harder than a song that's like staying the same pitch or just having minimal changes. Then the last one is rhythm. This is to account for any sort of like syncopated rhythms. So we've generally noted that rhythms that have upbeats and like are like off beat in general are harder than rhythms that are on beat. So this rhythm, even though it's not reflected in the this piano etude, it's designed to account for those syncopated rhythms. And then you get, when you add them all together, you get this overall difficulty rating. So I can show you right now, the third measure has a difficulty rating of 19.56, and it looks like this. And you can see it's like a bunch of 16th notes lined up right next to each other. Compared to this fourth measure that only has a difficulty rating of 9.8, we see that it's just 5 notes, 8 notes to be certain. So we can see that these difficulty ratings reflect how difficult these parts are, and in turn, how long you should practice them for. Now, I'll hand it over to Naveen to talk about the Midi processing.
Yo, hello? Okay, behind the scenes stuff. MIDI files are annoying to work with unless you use some kind of library to deal with them. So I used MIDI CSV to convert the MIDIs into CSV. And then you can see here, it's just this big list of instructions. And then I created these note objects, and these are what are going to the algorithm, to the UI, to everything like that. And so if we were to run it again, and this time I'm going to choose a different MIDI file over here. So he already kind of showed you there's a graphical display of each measure. And so if we were to look at the total thing, you can see this is quite a complicated piece, but this is made in processing, and it's just a representation of all the notes visually. And then I don't know how this audio is about to sound, but you can also put it back through that tool and have it play the measure for you. So if I were to play the whole thing, okay, it's not playing the whole thing. HDMI chords. Imagine it was playing the whole thing. It actually does play the whole thing. It actually does. It's just not playing right now, like for real. Yes, just imagine what it sounds like. Okay, so, and just like he showed you, you can isolate each measures. Isolate, huh? That's the name of our thing. Watch, you can look at the third measure as well, and just like that, you could play the first measure, play the second measure, and all that kind of stuff. So, any closing remarks?
Okay, so before we end this off, I just want to start off by saying that this is our first HowdyHack, and we were really nervous going into this. And I just want to say that this couldn't be done without William working on the UI, Jeffrey helping me on the algorithm, and Naveen working on a bunch of this background stuff that I have no idea about. So in our closing remarks, we just want to say, happy HowdyHack.
Okay, awesome job, y'all. Okay, next we would like to invite pitch.io. Come on up. Woo! Yeah.
What if I just played it right here?
Do y'all have a Mac?
We have an adapter.
Okay, awesome.
Excuse me. We have 5 minutes. Could you just test audio before we start?
Should be this thing. Could try connecting on that side. Okay, let's speak. I think that works.
That works.
Pretend you didn't see that.
Alright.
Okay, my name's Carolyn,
I'm Rayo.
I'm Luis. And I'm Jeremy.
and together we are pitch.io, here to give you our pitch. So, basically we created a relative pitch trainer. Oh.
Keep
Is it
talking.
so? Okay, yeah. We created a relative / perfect pitch trainer. So personally, I've played piano since I was 6. And throughout the years, like, I've mostly only learned from sheet music. Basically, just like, it tells me what to learn and I learn it. But I've always like wanted to be able to listen to a song and just like figure out the chords and just like play it on my own be able to just play my favorite songs without having to rely on sheet music, and just to make whatever versions I want and transpose to whatever keys I want. So recently, actually like last week, I met a friend who's like amazing at piano, and I asked him where he got his sheet music from, and he told me that he just like learns it from hearing the song and actually just like making the arrangements himself, and they're actually really beautiful. I kind of wish they had sheet music for it. But so I asked him what his secret was, like how he learned that, and he doesn't actually have perfect pitch or anything. He trained himself to have a relative pitch. So he recommended me to a website that he used. And this website basically trains you to have relative pitch. So you can pick out what chord progressions are in a song and what melodic progressions, and be able to like play in any key and stuff like that. So I looked at the website, and it was a pretty bad UI. Like, it was not good for beginners. It was not beginner friendly. It was really confusing to use, and so I looked for other websites, and I looked for mobile apps even, and I wasn't able to find anything that really that I could get addicted to and I can see myself actually spending time learning. So we decided to make a relative pitch trainer ourselves. So Rayo will walk you through it.
Yeah. So this is our web app that we created using React. And we have three modes. We have the relative pitch, we have the chords, and we have this sandbox. So I guess we'll go off and start with the relative pitch. So it's a little bit bugged because of the screen size, but ignore that for now. It was 24 hours. We're going to start by playing the reference note, which is going to be everyone's favorite, C4. So once you hear that and you kind of remember that note, you're going to play a mystery note. So does anyone know what that note is? Maybe you over there might know that. B. B what? High one. So yeah. Where's this one? So that was right. So now we get the next note, which is F sharp. Where is that? Here. It was right. Good job. Yes. Paid actor. All right, so that is our relative pitch with one note. But if that's too easy for you, maybe like him, that's too easy for him, you can go to the chords. So instead of one note, we can do chords. So how about a C major? Well, we know the C major. Let's listen to a different chord. Do you know what that is? D. Which one? Is it this one? Oh, this one? E flat. Which one? This one? This one? Oh, say E flat? E flat. Ah, that was on Carolyn. So that was the chord progression. So I guess that was too easy for him as well. So I guess if it's too easy for him, then he gets to just play on the sandbox. And it's just a piano. And obviously you got the C4 and the D. What's before that? No, it's C, B, A, and you keep going. But if you're too lazy to click on it, you can use the keyboard. And then you can also play.
Keyboard, not the mouse.
And that's how you can have fun if you are too good for the game, like him over there. So, this is Pitch.io, and I hope you guys enjoyed it.
And I promise the UI looks a lot better on web and not on a projector like this. Thank you.
Awesome job, y'all. Thank you so much. Can we please welcome Vism next? I'm sorry if I'm pronouncing it wrong. Woo! Yeah! Yeah, so this is the display. And if you have a Mac that you want to display from, we do have a converter.
Okay, and where is that?
I
Do you have
can't.
just an HDMI converter? Sweet.
Oh, sorry.
Got
Here.
it.
Yeah. I got multiple. Thank you. Do y'all need audio? This is the audio. Okay, awesome.
Okay, cool. Where is it? What? Help? Oh, cool. Oh. Help. Cool. Ready? Okay. So this is Vism, sheet music for the visually impaired.
So when we started this hackathon, we looked at the industry software that we have for creating sheet music. And there's tools like MuseScore, LilyPond, and OpenMPT. And these software are all great. You can go in the application, you can enter in specific notes, and you can get a PDF of sheet music. And that works. However, that really leads us to a lack of inclusivity for the visually impaired. Artists need to be empowered with a way to serve those with visual disabilities by being able to export to a Braille file or a BRF file, so a Braille ready file. So the goal of this project during this hackathon was to help blind Aggies learn how to read music.
So as Joseph said, currently musicians share their sheet music through software such as MuseScore, which will then convert that Muse file to a PDF, which will then be distributed throughout the world. However, that does leave those with visual impairment and blindness behind because a PDF cannot be read or embossed, which is just a fancy term for printing Braille.
So as Mason was saying, the Muse file with PDFs can only be converted to Braille with transcribers, which are people that know both sheet music and Braille, which is really expensive and time inefficient. So what we wanted to do is create a software that would work in conjunction with music notation softwares like MuseScore and directly convert your MuseScore file to .brf, so people can just directly export their music notation to a Braille file, and we can just send that to a printer and it will print Braille sheet music.
So some of the challenges we had when making Vism was the complexity of Braille sheet music itself. Knowing sheet music is not exactly a prerequisite. Well, it is a prerequisite, but it's not a guarantee that you know Braille. It's essentially a whole new language. And we needed to know how to read sheet Braille before we could write it, obviously. The second challenge was the lack of documentation for Braille file types. As Mason and Nitin both said, our end goal is a BRF file, and there is very, very little on the internet about BRF file types. So we had to do a lot of experimentation and trial and error to see what kinds of BRF files work best. The Duxbury standard license is the industry standard software required to optimize the BRF for embossing. Essentially, if you have a BRF, before you can send it to be printed, you should run it through Duxbury to make sure that it doesn't break somehow. And in the future, we plan to set up a remote server on our website that can hold the sole license, allowing our customers to use it as needed.
Oh, cool. Okay, this is kind of weird. All right, can you guys see that? Okay, cool. So it's kind of hard to see, but basically right here we just have a normal terminal. And if we just pwd, we can see the current directory we're in is the MuseScore content itself. If we ls, we can see the actual files we're using to work with MuseScore. And on the top right, you can see there's a shell file or shell script. So all we have to do is basically run the shell script. And on the left side, you see this output directory, which should output a MIDI file, a PDF of the sheet music, and a .brf. So if we run this, should take a couple seconds. So yeah, so I think I'm clicking the right one. All right, cool. Wait.
Yeah, it's here, it's here.
Oh, whoops, I have to drag it over. Okay, so that's the sheet music, and we also create a MIDI file, but I don't know if you guys.
That's not really important.
Yeah, it's basically just converts to an MP3. I don't know if you guys can hear this, but oh, it's on my laptop. And finally, we should convert to a Braille file.
Right. The end goal was a Braille file, and Mason's on this. Oops. Oh, no. It's trapped.
Cool. And so this BRF file is what Vism is at its core. This is what allows the visually impaired on our campus to participate in the extracurricular activities that they want to. Now with Vism, those blind Aggies can now play with other musicians and read sheet music because we provide the note, interval, accidental, and any other information that they need to read and play sheet music. And since this is a BRF file, it can then be taken to the copy corner and printed out in Braille. And as Ethan said, there is a licensing issue, and so we've made a website for Vism, which will then, in the future, host the Duxbury license, so our users don't have to pay for it, because in the end, it's very expensive. So thank you. This is Vism, and gig 'em.
Okay, so awesome job, y'all. So next we have the virtual hacker submissions that are also in the top 5. Let us get that pulled up for you. Okay, it's up there. Oh, you got it. Okay, so Modify.
So what is Moodify? Moodify is an idea that our team envisioned to meet the goal of resolving the challenge behind choosing music and making it easier to do so. We're inspired by our own lack of decision making. Would it be better for there to be a way to choose music based off our current moods? So we developed Moodify, a way to offer a dynamic playlist that adjusts the music selections based on the current weather. For our project approach, our app gathers the user's location. The different moods are based on research that reflects upon the weather. For example, sunny weather is correlated with happiness, since exposure to sunny weather releases serotonin. Although the user can adjust the preferences behind their listening experience, and we give them different options to do so, we want to make it as easy as possible to play music behind one click of a button.
During the app creation process, the worst challenge we came across was the pressing time constraint and the learning curve that all of us had to experience this with. Due to the fact that only 2 of our team members had a MacBook, we had to figure out a way to work around it through Zoom meetings.
So our project, we basically mainly use Swift, which is iOS development tool, and we also use Figma as our UI development tool. And so this is our demo of our application. So as you can see, the login, we have a login page for the user, and then after you log in, they will see ideally a window on the top that shows their weather condition of their current location. As you can see, we have the information here. And so on the bottom here, we have a couple music lists or albums that ideally should be what the app think would be ideal or fit for the user's current weather location. So basically, they're the recommendation of the songs. And you can also click it, and then it plays music, and then you can pause it. You can also, I believe, swipe. Oh, I don't know how to swipe up. Anyways, so on the menu, there's also a couple options designing for different music hosting APIs. And yeah, go to the next slide.
For our future goal, we wanted to implement more dynamic theme into the background to notify you of how and to also set the mood, such as rainy weather, nighttime, and other weather conditions. Furthermore, we wanted to integrate Spotify and Apple Music and other music resources for this to be able to dynamically curate you a playlist based off
Woo! I don't know if y'all are watching virtually, but congratulations, y'all are doing amazing. So the next one is Party Vision, also a virtual submission.
Howdy. Our team is Control Alt Elite, and our members consist of Shion Ito, Raymond Lin, Brandon Pham, and Leandro Alquianto. Our project is called Party Vision. Party Vision is able to play genres of music based on the number of people detected in a given space. Let Party Vision make the music choice while you make the memories. So here's just a high-level overview of the code we written for this project. Over here we have 3 main source files that are broken up for the 3 components used to comprise of the whole system. Our first one is the camera object, which uses OpenCV in order to detect humans. Our second, we have our motor object, which uses the GPIO pins on the Raspberry Pi to sweep from left to right as the camera detects humans in the vicinity. And the last one is the music Pi, which is pretty much where we pull music from an external library, which we categorize into 3 groups that will be then played based on the group size detected.
You're angry? Huh? Are they angry?
Yeah, so we're going to exit space.
The what?
Let's go to the room and get flyers.
Is it exit?
Yeah.
Can you tell them it'll take like 5 minutes?
5 more minutes? Okay.
10 minutes. Okay, so that was our top 5. Give us like 2-3 minutes to decide who the top 3 are, and we'll be right back to you. Y'all should talk and think who you think the top 3 are. Okay, that's right.
Okay.
We
I'll
don't
look
have to.
Where's the
We don't have to
notes?
script. You want?
Okay, can we settle down, please? Oops.
Okay, we have it.
Okay. So the judges have come to a conclusion. Let's get into it. In third place, we have Party Vision. Woo!
Yeah, virtual.
They are virtual though, so I hope they're watching from home. But next, in second place, we have Vizzo. Woo! Okay, and then last but not least, in first place, y'all. First place. Woo! Okay, Isolate. Woo! Come on up, everyone. Second place too. Vism and Isolate, please come on up. Okay. Yeah. So first place gets to choose their prizes first, and then the second team will get to choose their prizes.
Actually, she said that we can stay to the six.
Okay. Oh, thank God.
Okay, that was like, oh my God. Okay, congratulations, everyone. Okay, we're not done yet, so give us like 5 more minutes. Okay, so y'all have a choice between the mini projector, noise canceling headphones, and mechanical keyboards. Y'all have to choose the same one, so. Headphones? Okay, so first place got Sony noise canceling headphones. Woo! Okay. Y'all want to start deciding what y'all want? Okay. You know what you want? What y'all want? Okay, awesome. Okay, awesome. So next, Vism got mechanical keyboards. Woo! Awesome job, y'all. Okay, in third place, Party Vision gets mini projectors. Woo! Okay. Okay, so that wraps up the project prizes. If y'all have any questions, concerns, or feedback, please feel free to reach out to us at TAMUhack. Okay, so next we would like to take a moment to thank our mentors, judges, and volunteers. We would not have been able to host this event without y'all, so y'all pretty cool. Okay, so if y'all had fun today, these are some other hackathons coming up nearby. And this was a lot of y'all's first hackathon, so even though it was a long weekend, y'all submitted some amazing projects, and you should be proud of yourself. So please feel free to look into these opportunities if you're interested. Okay. Okay, so if y'all like what y'all saw today or didn't like some things and want to change how the event ran, please fill out this form if you'd be interested in becoming one of the organizers that lead HowdyHack and TAMUhack. It's an amazing opportunity. You meet some great people and you get a lot of great experience leading these hackathons. Okay, so before you leave, please clean up your space and recycle any water bottles or trash that you may have. And at any time, if you come up to the front and let us know if you have any questions. For those of y'all virtual hackers, let us know on Discord. And make sure you take all your belongings. And thank you so much, everyone. Woo! Y'all did it!